let's solve this problem where we have 2x squared d square y dx square plus 3x dy dx minus 15y equal to 9 ln x. So this one's still Euler equation that we need to transform into the general form of second order ordinary differential equations. Okay, so we use the same method before, so we will have our general form as 2 d square y dt square plus with 3 minus 2 dy dt minus with 15y equal to 9 ln exponent t. Okay, therefore what you will have here is 2d square y dt square plus with dy dt minus with 15y equal to 9t. Okay, so this one is non-homogeneous second order ordinary differential equation that we can solve by using undetermined coefficient. But first of all, we need to find what is yc, where we will take the left hand side to be homogeneous differential equation. Therefore, we will have 2d square y dt square plus with dy over dt minus with 15y equal to 0. Okay, transform it into characteristic equation. You will have 2 lambda square plus lambda minus 15 equal to 0. Okay, and if you solve this by using calculator or manually, you will have your lambda 1 equal to 5 over 2 and your lambda 2 is equal to negative 3. Okay, therefore for this kind of case, your solution yc will be a exponent 5 over 2t plus with b exponent negative 3t. Okay, so we have done with yc. Let's move to find yp. Okay, so now we have our fx as 9t. This one is a polynomial, so it's easy for us to just compare it with cx to the power of n e to the power of rx. Okay, so let's do a comparison to decide what is our yp. So our c is 9. Now x is t, so we change x to t. Okay, so our t is t to the power of 1 and we have no exponent, therefore our exponent is actually 0 times t equal to 1. Okay, so from here we have our n is equal to 1, our r is equal to 0, and because of r is not same with any lambda here, therefore our s is equal to 0. So now you can decide what is your yp. Your yp will be x to the power of s, so x to the power of 0, a1x plus a0 exponent 0x, so you will have your yp equal to a1x plus a0. Okay, so now we want to find what is our yp prime, where your yp prime is a1 and your yp double prime is equal to 0. Now what you need to do is you need to substitute your yp double prime, yp prime and also yp inside your differential equation here. Okay, so you have two double derivative here, so you have 2 times 0, you have 2 times 0 plus with a1 minus with 15 times a1 t plus a0 equal to 9t. Okay, so for correction we need to use t in term of, because everything is in term of t. Okay, so we need to change our x into t. So we have t to the power of 0, a1t, so here is a1t. Okay, so we expand our equation here. What you will get is a1 minus with 15a1 minus with t minus with 15a0 equal to 9t. Okay, therefore you will have negative 15a1t plus with a1 minus 15 a0 equal to 90. Okay, so you do a comparison, the same term here got t and here got t. So what we will have here is negative 15 a1 t equal to 90. So cancel out the t here. So negative 15 a1 equal to 9. So you will have your a1 equal to 9 over negative 15, where your a1 is equal to negative 3 over 5. Okay, so now we already have our a1, we can find our a2, our a0, sorry. So you have the second equation here, a1 minus 15 a0 equal to 0, nothing here. Alright, so we can write our second equation as a1 minus 15 a0 equal to 0. So we already have our a1, negative 3 over 5 minus 15 a0 equal to 0. So negative 15 a0 equal to 3 over 5. Therefore, a0 is equal to 5 over 15. Is equal to 1 over negative 1 over 25. Okay, so we already have our a1 and a0. We can substitute it inside our yp here, the value of a1 and a0. Therefore, we have our yp equal to negative 3 over 5t minus 1 over 25. Okay, so we already have yp, we also have our yc. Therefore, our solution is equal to y equal to yc plus yp. So our yc is exponent 5 over 2t plus with b exponent negative 3t. Okay, plus with yp here, minus 3 over 5t minus 1 over 25. Okay, don't forget that we need to substitute t is equal to ln x. Therefore, what we have here is a exponent 5 over 2 ln x plus b exponent negative 3 ln x minus 3 over 5 ln x minus 1 over 25. Okay, so we bring the coefficient to be a power here. So what we will have is a exponent ln x to the power of 5 over 2 plus b exponent ln x to the power of negative 3 minus 3 over 5 ln x minus 1 over 25. Therefore, exponent and ln can be cancelled out here. Okay, so you left only with a x to the power of 5 over 2 plus b x to the power of negative 3 minus 3 over 5 ln x minus 1 over 25 as the solution to your second order differential equation.